It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about continuity of a function at a number with a given piecewise function. Let us try to determine if the function is continuous at the given number c for f of x equal to square root of x squared minus 4 if x is less than negative 2. F of x is equal to square root of 4 minus x squared if x is greater than or equal to negative 2 or x is less than or equal to 2. F of x is equal to square root of x squared minus 1 if x is greater than 2. Our c here is equal to 2, in which we try to check whether function is continuous on that particular number. So let's start off with checking the first condition. First condition, we are to check if our f of 2 exists. So f of 2, we are to choose between those three functions as to what to use. But first, let me just draw or illustrate the domains of every function so that it will be a lot easier for us to determine later on. First, we have negative 2 as our basis. Negative 2. And then, the domain here are all gonna be to the left of negative 2 because we've got a pointer of your symbol there pointing to the left side. So that means to say, we're taking up this part of the number line. And then we don't have equal symbol there, so that means this one is a hollow. That means negative 2 is not included or part of the domain. Going over to the second function, drawing the number line, we have the basis here as our negative 2 and the positive 2. Once we say x is greater than or equal to negative 2, which means this negative 2 is included, and the values that are gonna be greater than the negative 2. Because again, our x here is greater than or equal to negative 2. So this one here, okay, that one. And then we have x is less than or equal to 2. So which means if this is our 2, this will be also equal, which means that we are considering the values here to the left of 2. Now going over to our third domain or third function, we have the basis here as a number 2. And then checking up on the domain here of your function, x is greater than 2. The pointer here is pointing towards the right side of 2. So that means we're moving or considering the numbers that are located at the right side of 2. This one is without equal symbol, so that's a hollow, meaning it's not included. Okay, now going over here, if you try to look at that, I'm looking at the tail part of the symbol. Notice that the way it is written is gonna be starting off with an x. If it's gonna be like this, we will always have to start with our x as well. Notice our x here is greater than or equal to negative 2. So meaning to say, since x is greater than negative 2, we are considering the right side of that one. So if you notice, this is inverted as to how I usually take this kind of way of writing. So once you got it like this, just think of the number here, negative 2 and 2 as the boundary of the interval. So let's now consider our f of c as your whether f of c here exists. So we have f of 2. Where can it be? What type of function are we considering our 2 as part of the domain. So checking up our 2 here, which is closed, this is on the second domain. We will be utilizing the second function, which is square root of 4 minus x squared. So plugging in, we've got square root of 4 minus x here is 2. We square that one. This is now f of 2 is equal to square root of 4 minus 4 for 2 squared. That will be equal to the square root of 0, which means our f of 2 is equal to 0. This would signify that our f of 2 is existing, so we go on to the second condition. So since this is again a piecewise function, we'll be checking on the limit from the left side of our function. So limit of f of x as your x approaches, the c value which is 2 coming from the left side. We're now considering on the values coming from the left side of our 2. Notice we don't have our bases here as 2, and the values here are coming from the left side of negative 2, so there's no way for us to use the first function. Looking at the second function, we've got the number 2 here, and values here are also coming from the left side, approaching to 2 coming from the left side. So that means to say that we're considering the second function as our function. So we have now the limit of your square root of 4 minus x squared as your x approaches 2 coming from the left side. This is equal to, we have square root of, this time, since this is square root, we have to double check our values here whether we are going to get a negative result once we input our values on x that are coming from the left side of our 2. So considering our interval here, again, this is a radical function in which we cannot have a number inside which is negative. So that means we need to check thoroughly if there will be a number that will make this one a negative. So checking up our domain here of the second function, we only have until negative 2. So once we try to move closer to 2 there is no actually problem with it, because it will always be moving closer as well to the value which is 0 on y. So we're literally plugging in the value 2 here. So 4 minus 2 squared, that will be equal to the square root of 4 minus 4, and that is equal to the square root of 0. So we've got our limit of f of x coming from, as x approaches to 2 coming from the left side, which is 0. So we will be checking up whether our limit, which is of f of x as x approaches 2 coming from the right side, will also be with the same value as 0. So on the domain there, we have the 2 here, and we are to consider domains that are coming from the right side of 2. So checking up, we have the third domain here, because you notice values are coming from the right side of 2. Although 2 is not included, but as long as you are moving closer to 2, that's really fine. So we're choosing on our function, the third function. So we have limit of x squared minus 1 as your x approaches 2 coming from the right side. So substituting that x there by 2, we have 2 squared minus 1. Square root of 2 squared is 2 squared is 4, so we have square root of 4 minus 1. which is square root of 3. We have now the right-hand limit. Our limit of f of x as your x approaches 2 coming from the right side is square root of 3. Comparing the two limits, the limits are not the same. So we can now say that our limit of f of x as x approaches 2 is a DNE. So since our limit there does not exist, second condition is not met, automatic, we do not go through with the third one because our f of x here is discontinuous. Discontinuous at c equal to a 2. The type of discontinuity here is, again, essential, or that is a jump.